This is the tutorial video for uPlatformer version 0.2. uPlatformer is, of course, the platformer solution for your Unity game, and 0.2 added the ladder system. Of course, all platformer games are going to need a system where you can climb up and down ladders, and that is what we have here. And it's not 100% perfect. I would like the animations at the top of the ladder to be a little bit better. But this is beta, and for each beta version, each beta release, we're adding new features. So, of course, this one is the ladder system that we're adding. So thanks for your support during beta, and any feedback as far as problems that you're having with it is definitely helpful. Now, I am doing a giveaway just for the subscribers. Maybe you hadn't had a chance to purchase this yet. I'm going to pin a comment down below with a voucher for the asset, so the first person to grab that, redeem it on the asset store, go ahead and grab that, and then I will take away that pinned comment. So if you don't see that, it's already been redeemed. It will probably go pretty quick. And then as far as how to use this tutorial, it's gonna get pretty long, and so you know, unless you're really digging in to learn uPlatformer, it's not meant to be watched from start to finish as a hour-long thing or whatever. But the way it's supposed to work is you should get uPlatformer, go to your documentation file, open that up, and then what you'll notice that on each section, like import the character, you'll see video tutorial button. That video tutorial button leads to a certain time point in this video, and so you can just click here, go to the part of this video that you would like to learn more about. There's also a table of contents in the description below, so you can check the description for the table of contents, and that covers the intro. So I'm going to disappear off the screen because I think I'm in the way of the uPlatformer folder right here, and then we're ready to get started. The first thing we're going to do is, of course, open up that documentation file, and the first part of it is just the introduction, some links to the tutorial, what is uPlatformer, and how to use it. Now, how to use is where I'm going to start. I did have the demo scene open, so I'm going to go ahead and create a new scene, and we're going to act as this was our own new project. I'm going to create a plane so the character has something to walk on here, and let's get started. Of course, the first part is about importing your character. Now, I've already gone to the asset store, and Script Inspector 3 is great, but I got the Kyle robot, which of course is free from Unity. You could bring this guy into your project. That's what I've done here. So I'm going to use Kyle as the example. And one thing you need to do is go to the model. This is what we're telling us here. We need to set the animation type to humanoid and make sure that it has an avatar definition. So I've selected the model. By default, this could be set to generic. And so you want to change this over to humanoid. Now that it's set on humanoid, I'm going to create an avatar from this model. And we, of course, want to import any animations. And we could set up any other options we want. But we definitely need to have this set to humanoid for the Mecanim animation system. So now that we have this set up, we're ready to go on to the next spot. Add the PlayerController Script. We're just going to select the robot, bring him into the scene. And now on the root game object, we're going to add the PlayerController3D Script. That's going to add a character controller, which we'll need to configure with these values. It's important to set the skin width to something smaller than 0.08. If your character happens to be floating in midair, like he won't put his legs down onto the ground, that's because the skin width is set to the default of 0.08. That's too high. We need to reduce that. We'll go ahead and use 0.002 as the documentation says. The next part is to set the center, the radius, and the height. Now this depends on your character and what they look like, but for Kyle I could see that this is no good. I'm going to want probably a radius of 0.3. A height of 2 is probably okay, but that means the center needs to be at 1. Now it's a little bit too big here, so I'm going to go ahead and reduce that height to 1.8. And the center needs to be exactly half of the height, of course. So I'm going to make that 0.9. And then I can see that that character collider size fits perfectly. So now that that's created and I have my skin width set to 0.002, I'm ready to keep moving on. So the next part is to configure the animator. Right now there's no controller. We're going to need to set that controller to the player anim controller. And we could also see that here in the documentation, player anim controller. And we do not want to use root motion. So on check, apply root motion. And now the animator is set up correctly. The next part is to configure the bone transforms. And if you click on this limb positions button, there's 3 transforms that must be populated before you play the game, press the play button. And that is the left hand, the right hand, and the back of the head. The left hand and the right hand, just go through your character's armature and find what would represent the left and the right hands. And for Kyle, I could see here it's all the fingers, and so it's always the parent of that. In this case, it's called the wrist joint. And so this is the left hand right here, and this would be the right hand. And the next one that we have to set up is the back of the head. Now the documentation explains this pretty well, but we need to create a new game object so that we have a transform that's located directly at the top and the back of the head in this position exactly. So I'm going to go into Unity, and this should be a child of the head. So I'm going to locate the neck, and there's the head. I'm going to right click and create empty. This I'm just going to call back of head, and I'm going to position this directly at the back of the head. Now you could get pretty close in 3D mode, but if you really want to get accurate, click here to go into isometric view, and then I'm going to click here to get the Z axis, so I'm looking back to perspective. That was the wrong thing to do. I'm going to rotate the camera so I get these views, and I click on the X. There we go, and now I have the isometric view, and I can get it lined up here with the back of the head, and then, which is this line, and the top, which is this line. Now that's going to have a Z-axis of 0, so I know that's going to be right in the middle of the head, which is correct. And that would be the position for the back of the head. So now I have a transform for the back of the head. That's what needs to be assigned to the back of the head transform here. So now that limb positions have been populated, we're ready to go on to the next part, which is configure the camera to follow the player. So we're going to select the main camera, and we're going to add a component of CameraFollow3D. CameraFollow3D needs to have a player assigned to it. The player is the PlayerController3D Script, as you can see here. So we're going to just drop the player's game object, and the camera will now follow the player. Now you can configure some options here, and those are going to be covered a little bit later in the documentation. The focus size, Z-axis, offset, vertical offset, and whatnot, the smoothing. We'll cover those options further on in the documentation. And for now, we're just going to stick with the default values. We've added the CameraFollow script. And now we're ready to move on and add the input system. An input system is required before we play. So I'm going to create a new game object. I'm going to call this input system. And we could see from the documentation that we need to add a Unity input manager. So I'm going to say add component Unity input manager. And the way this works is that whatever this string value is, it matches up to the input manager here in project settings. You'll see that the name here, horizontal, vertical, fire 1, 2, 3, jump, that is the same that matches here. So the game uses these inputs: horizontal, vertical, run, crouch, jump, attack, cancel, and submit. And so these are matched to those Unity input mappings. So this by default uses the Unity input manager, And of course, it can be switched to a different input system like Rewired. And now that I have the input system configured, your character is ready to play. And after this, we're going to dig into the Player3D class itself. But if I hit play, my character should be able to run around, walk around, crouch. If you were to create something like a cube and it was too big for the player to jump up onto, he should have no problem because he can jump up and grab and climb up. And if the player controller is on the climbing set to allow climb ladder, and you were to create a different game object that has the tag ladder, and that game object was some kind of a ladder in the game, then your character could walk right up to it and climb it like a ladder. So everything's working with our new game and our own custom character. Now let's move on to looking at the class itself, the PlayerController3D Class, and all the variables on it. The first one is the Player Info tab. And so we're going to go here, we're going to go click onto the robot Kyle, and we're going to go to the Player Info tab. The current state is the current state that the character is in. Right now he's in standing, and if I crouch, he'll be in crouching, and if you jump, he's going to be in jumping, but try this again. If you jump, he's going to be in jumping, and then when his jump is completed and he starts going down, he's going to transition into the falling state, and when he hits the ground, he's going to be back to standing. And of course, when he's on the ladder, he's going to be in the climbing ladder state, and if he's grabbing onto an edge, he'll be in the edge grab state. If you want to see all the states, you could go to the PlayerController3D Class and look at the public move state. Standing, jumping, falling, crouching, edge grab, climb up, edge grab, drop, and climbing the ladder. Those are all the different states that the player could be in. And while a state is active, a different section of code is being run during the update function. Okay, so that is the current state. Then we have the ground state. Now the ground state just tells you information about the player's relation to the ground below him. And right now it said flat ground, but what I'm going to do is go into the scene, duplicate the plane, and then rotate a little bit. Now if I walk over here and we select here, we can see flat ground, and when I go onto this, it's going to say uphill because it knows the player is on uphill ground. So the ground state is information about the character's relationship to the ground below him. And so if you're going this way, the character's actually walking flat. He's not going up or down on the y-axis. He would be walking completely flat. And so you'll notice that it says flat ground. And then, of course, this way it's going to say downhill. Now, before I go any further, I'm just going to switch over into a demo scene. So I'm going to select Demo Scene 3D. And actually, I don't need to save that scene. Okay, so the reason why is because we have some nice slopes here to test with that. And if I select Player 3D, we can see that the ground state is uphill, downhill, and of course, flat ground. And then distance to ground tells you how far away the character is from the ground. It's not going to be exactly 0 when he's on the ground because of the skin width. He has a little bit of distance between him and the ground. So the distance to ground is not going to be exactly 0, but it's going to be really small when he's on the ground. And of course, when he jumps, it'll go. Or if he's up high in the air, it'll tell you exactly how far away the character is from the ground. You can parse that variable in your script if you want to know how far away the character is from the ground. You can see when you climb a ladder, of course, it's gonna go up as well. So if I'm here on the ladder, I could see that it is he's 2 units off the ground. So then we have grounded, which is just a Boolean true or false if the character is grounded. And this is more accurate than the character's controller dot is grounded. This has a boolean itself, but this is a lot more accurate. It's actually going to tell you if your character is on the ground or not. And so when he's jumping, it's going to be false, and when he's climbing a ladder, it's also going to be false because his feet are not on the ground. Then we have player ID, and this really isn't used for anything at the moment, but it is for multiplayer, or for a game where you might have multiple players in it. So this is just reserved for future updates when we officially are supporting multiplayer. And then we have raycast collision mask, which the character controller itself, which is the green capsule around him. What does he collide with? What objects does he collide with? Right now it's everything, but in a real situation, you probably would have some transparent effects like particle effects that you don't want him to collide with. Objects that are on the ignore raycast that you don't want him to collide with. And so that is what the raycast collision mask is for. The player is only going to collide with objects that are set to these layers. And then we have debug mode. And debug mode shows you useful information in the scene. So, for example, here is showing the forward direction from the player. That's just drawing the player's forward direction. And let me show a good example. Something to help out here is if you were to take the game window, dock it here, now we could see both the scene and the game. And what I'm going to do is go do an edge grab, climb, jump up and grab onto this edge. Now when I grab onto it, you're going to see it's calculating a Bezier curve of where the player controller itself is going to travel as it goes up when he climbs up. And it's going to recalculate that when I actually perform a climb up. So let me do that now. And you can see that it drew with the red line where the player controller was moved as he climbed up. So this is because debug mode is on. And if you uncheck that, of course, debug mode is going to be, you're not going to see all the different debug information that's drawn in the scene. So debug mode is useful for a lot of different stuff if you're trying to figure out what's going on and see the raycasts and stuff like that. So moving on to the documentation, well, we're going to be on the movement tab. So let's go ahead and move on. We got the movement tab, and let's go through the different variables here really quick. You got walk speed, which is the speed the player is moving when he's walking. If you increase this, he's going to be going faster when you walk. Okay, slow down. If you go 1, you're going to be going way too small. Way too slow. Okay, so I'm going to put this back to 3. That's a good walk speed. And run speed is the same exact thing. If you hold your run button, default is shift, it's 6. And so if you made this 12, he's going to run twice as fast. Alright, so the next one is turn smooth time, and the fastest way to easiest way to demonstrate these is just to set it down to 0, and you'll see the difference. So if I set the turn smooth time to 0, now let me make a turn. You're going to see the player snaps instantly into whatever direction you're turning to. So you want to smooth that out a little bit. So that's set to 0.2 by default. Now I have some nice smooth turns. Now the next one is the speed smooth time, which is, again, it's smoothing the speed. You can see here I'm running and walking, and it's just instantly snapping to that speed, which is not that great. We want to have a little bit of smooth right there so that the character is smoothing into those speed changes. And the same thing is for the input. This one is not as easy to see when you set it to 0, but what this is doing is, let's say you have a controller and you're just jerking the joystick all over the place. Instead of having that direct one-to-one input, this is going to smooth out the input just a little bit, so that as you rotate that joystick on the controller, you get a nice smooth input from that. And the next one is lock Z-axis. This is for your game, whether you're going to lock the character into a Z-axis, and if you do, what Z-axis? Right now it's set to 0, so the character is at a Z-axis of 0. You can see that right here. He's at a Z-axis of 0, and he's not going to be able to change from that. So if I push the up or down button, it doesn't do anything because he's locked in. So this is a 2.5D platformer game, and he's locked into whatever z-axis you put here. If I put something like -20, I'm going to be way out here, and now I'm locked into the z-axis out here. The character can't go anywhere but a z-axis of -20. And so that's lock z-axis. I'm going to turn that off so that I can run around freely. And the next part is crouching. So let's click on the crouching tab. And then we got a couple variables. Crouch speed, self-explanatory. What's your speed you're moving when you're crouching, and if you go 6, you're going to be crouch moving too fast. I got it to 2, and that's slower than a 3, which is a 3 speed as a walk. So you're going slower than you walk. And then this is static character controller bounds when you're crouching. It's a little bit hard to understand, so let me explain it like this. When your character is standing or doing anything, running, the character controller bounds, the height and the center, are being calculated in real time. You can see it's changing just a little bit. And the reason for that is that as you move around, is say I do a jump. So I'm going to do a jump. Now you can see that normally when I set this up, it was a height of 1.8. But my character's not that high anymore because his legs are bent and his feet are, you know, up here. His head's brought down. So he's actually at a height of 1.3. He's gone from a height of 1.8 all the way to 1.3. That's just at a jump. And I think it's important to have this character controller size change because let's say you have bullets being shot at you or anything like that, you're going to need, you know, you wouldn't want your feet to be getting hit if you know, the bullet actually wasn't hitting them. So it's important to resize this character controller at all times. That's why it's constantly being resized, and the back of the head transform is being used to calculate those bounds. So there's a problem with this when it comes to crouching. Let's say I want to design my game so that I have a 1 unit size, and I know my character could crouch under a 1 unit. So I come over here and I crouch, and he doesn't fit. The character controller is too big, and in addition to that, it's constantly being changed in size. So maybe if this was up a little ways, he would fit, and then after he walked underneath of it, he wouldn't fit anymore because he's getting bigger. So if I could squeeze, you can see here I'm like barely squeezing under. Now I made it, but now the character controller is like pushing up into that. So it's not any good. That's what the static character controller bounds while you're crouching is for. You're going to set this. It's going to say what height do you want your collider to be when you crouch, and I'm going to say 0.09 or 0.9. So I crouch down. It instantly snaps to a size of this, which is, for here, it's 0.9. Now I know my character can fit into an area which is only 1 unit high because he's only 0.9 high. So he's going to fit inside of anything that is 1 unit high he can crouch underneath of. So I hope that explains the character controller bounds static while you're crouching, and also the character controller crouching height, what heights you want them to be when they're crouching. And the next part is the crouching head clearance. And the easiest way to show this is to go underneath of a cube, or go, you know, crouch underneath of something, and then select that object and drag it up and see when your character stands up. So I'm going to go up, 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 and when's he going to stand up? There it is. Now there's a little bit of head clearance there, so I could actually make this number lower. So if I put this down to a 1, now I'm going to bring this down again. I'm going to crouch. Alright, so it only needs 1 unit clearance, and then the player is going to be clear to stand up. So here we go. Now you can see a 1 is not enough because he thinks he can stand up, and now his neck is going into the ceiling. That is no good. So we need to adjust the crouching head clearance. I'm going to put that up to a 1.2. I'm going to crouch again. I'm going to bring the box up and see when he stands up. 1.2. Well, 1.2 is close, but it's going through his eyeballs. So we're going to go back to the player. We're going to set it to a 1.4. And I'm going to crouch. So I'm going to bring this down and see when he stands up. Alright, at a 1.4, I can see that's a pretty nice value. I could even actually probably bring this one to 1.3 for this Unity guy because that looks like it's just about the correct head clearance for him. I'm going to duck and bring it up. Boom, right there. Well, he's still got his head clipping, so yeah, it's definitely 1.4. Now that is the crouching head clearance and the crouching tab. Let's go ahead and move on to the next tab, jumping. There is jump height, which is just how high does your character jump. The yellow box is 1 unit high, so I have a jump height of 1. He's just going to barely be able to, he's just going to barely be able to, those are physics objects, so jump up on top of those. And now if you put a jump height of 2, you're going to be able to jump up 2 units, which is the size of this box. Well, he'll grab an edge if there's an edge to grab. So jump up 2 units. And then if you put a jump height of 4, he'll be able to jump up 4 units. And jump delay is currently set to 0.025. The reason for the jump delay is the jump animation. When you push a jump animation, the character will usually bend his knees down a little bit as he builds up some spring to jump up. So before the character is his physics object is moving vertically up, you want to wait for a little bit until he's done doing the spring, and when he gets done doing that little spring, at that point you want to start moving the character up in, you know, on the y-axis. But there's going to be a little delay there as you wait for the character to bend down as he's doing his bending down to do his jump. So when you push jump, the character's crouching down, and then after this amount of time, he is going to move his character up in the Y direction. So your jump animation, maybe he takes longer to duck down, so you might need to modify this variable. Double jump is just if the character can double jump or not. And so if you put double jump on, he can jump once and twice. So of course that's going to be a height of 2. He should be able to get right up this object with a double jump because it's too high. And it doesn't play an animation or anything. I hope to make this better in a future version, but for now it's just a basic double jump. It does let you do that double jump while you're in midair. And then we have the falling tab. So we're moving on to falling. There's 2 variables, air control %, which is how much control you have while you're in the air. If I have 1, I have full control, which is the same amount of movement and rotation control as I would have when I'm on the ground. So if I run over here and jump, I could come right back. Run out here and jump, I could come right back. Or if I jump too far, I could come back and grab onto the edge. I missed it, but that's okay. So I have some control of the character while he's in the air. Actually, I have a control, 100% control. So if I put it to 0, he's not gonna. If he's in the air, it's gonna be more realistic to where, if you're in the air, you're locked into whatever direction you're going, and you can't you're not going to be able to change that direction until you touch the ground. So if I run and jump, I can't turn back at all. I'm completely locked in the air until he touches the ground and is able to regain control. So that's air control percent. So maybe I'll put it at 0.5, so he has 50% control in the air as you would have when he's on the ground. So I can run and jump and come back, but not as fast as I'm not going to turn around as fast as I would when I'm on the ground. So those are the two variables for falling. Then we have edge grab. Now edge grab looks a little confusing at first, but it is pretty easy to explain. The way the edge grab works is that you define a cylinder where it's going to be checking for an edge, and that is a cylinder shape. You can visualize it by looking like this. Okay, so I have the cylinder. Let me just make that a child of the player, and I'm just doing this to visualize it so you could see that you're defining a area that's somewhere like this. It's going from about the top of the player's shoulders, his arm length if he was in T-pose. So if he was put in his T-pose, how big would his arms be? So that's the size of it this way. And then vertically it's going to go from about the top of his shoulders maybe to his waist. So it's basically, you can imagine everywhere inside of this cylinder the character can reach with his arms. So this is the area where it's going to actively be checking for an edge. And this cylinder area is defined by the yellow circles. So I'm going to delete the cylinder, and let's look at this. The edge grab bound's bottom, of course, is the bottom of the cylinder. And edge grab bound top is the top of the cylinder. So and then the radius is the size of the cylinder. That's how far he could reach to grab an edge. So those three variables define the cylinder area where the player will be sensing for an edge grab. And if he could find an edge there, he'll grab onto it like he just did. And then the next one is the edge grab minimum edge size. And the reason for this variable is because within this area, it might be too small to grab onto. And what I mean by that is it's like this. And even though there's an edge there and he's going to detect an edge, it's too small for his fingers to grab onto and for him to climb up on. And that's what this variable defines, is it won't let him climb up if the edge is this size or smaller. So right now if I try to jump, he's not going to be able to grab onto that edge because it's smaller than a 0.02 size. Now if I were to move this over here, try again, okay, he could grab onto that. Now one thing to note about this variable is it can only be a size of half of your radius, because the edge grab size detection is only half the size of the radius anyways. It's detecting from the center out to here for the edge. So the radius, I'm sorry, not half of the radius, but the radius itself, 0.75. So from here to here is where it's checking. So this variable won't do no good if you set it to a 1, because that's actually bigger than the area it checks. So keep it really small, 0.02, maybe 0.03, and we'll see if he could grab on. Now, see, now 0.03 is not going to let him climb up that. we'll need to move this away a little bit more. And now it lets him climb up. So that's what the variable for edge grab minimum edge size is. And then we have edge grab climb forward, which is currently set to 0.025. That's easily visualized if you look at the red line. It's moving him forward. This distance is 0.025. So if you jump and you do an edge grab climb up, you'll see that it does this distance of a 0.025. And if I make this 0.5, things could be getting a little bit weird because he's going to be climbing forward way too far. Well, it didn't make it, but it tried. The red line there definitely is longer. Now we have it set to a 1, and he tries to get all the way up there, but if he hits the ground first, he's going to go to a standing position. So that's what the edge grab climb forward is for. How far is he going to try to move him when he goes climbs up an edge? And then we have the edge grab ray count. And for this, it's important to understand how the edge grab is detected. The edge grab is detected only within this cylinder area. And it's doing that with ray casts. And how many rays are going to be fired is defined here. So it's default set to 4. And if I do this just right, it's a little bit hard, but okay, here we go. What happens when an edge grab is detected is shown here in debug mode with the red lines being drawn to detect an edge. And it's drawing 4 rays, and they're within the area of the cylinder. And they're shooting out 1, 2, 3, 4. And then if the ray hits something, so we can see that this ray at the bottom is going to be fired out and hit. And so its length is this long. But the one above it has shot out, and it's gone even longer. So that it knows that there's an edge here because this one was short and this one was longer. And so the number of rays here is how many ray casts are going to be fired. If you were to increase this number to 8 rays would be fired, so the edge detection would be more accurate. Now, I'm going to have an option here for static character controller bounds when climbing. And you may or may not want to use this, but it's the same thing as the crouching variable static character controller bounds when you're crouching, to where while you're doing an edge grab climb up like this, it doesn't dynamically resize your character's collider. So you can see here how it dynamically resizes it, and when I climb up, the character's controller is going to dynamically resize with his actual body size. So here it's really small. And if you set this static character controller bounds while climbing, those bounds will not be dynamic when you climb up. It's just going to instantly lock into a 0.9 and stay that way. So right here you'll see that it's a 0.9 and it doesn't move from that value at all while he's doing his climb up. So that's what that variable is for. And of course the climbing height sets the size of his height while he's climbing up. And then we have the limb positions tab, which we've already covered, and that is the back of the head transform, and the left hand and the right hand. The back of the head is used to determine the capsule collider's size for that dynamic collider. Alright, the last one is the one that was added in version 0.2, which is called climbing. And I just called it climbing because I'm probably going to add rope climbing to this. But for now, it just has ladder climbing. And ladder climbing works like this. You just make a game object. It doesn't have to have ladder rungs like this. It could be anything, of course. And you just assign a tag of ladder to it. So I've selected this. I say tag ladder. If it doesn't exist, create it. And once a game object is set to ladder, if the player collides with that object, he's gonna climb right up it. So there's some options for the ladder, and let's look at those. You have allow the climbing a ladder. If you turn that off, it's, well, you can't climb a ladder anymore. That's all that does. Alright, and then the ladder cast length. When you bump into a ladder, or when you bump into anything, it's gonna check to see if it's a ladder. It does that with a raycast. The raycast is this far, and you don't want this to be very far, because if I set this to 0.5 instead of 0.05, well, what's going to happen is I'm going to walk up to this ladder over here. I don't think it's even working. Oh, I didn't say allow climb. Okay, there we go. You don't want it to be too far, because I don't know. Just because. You could put it at 0.05. That's what I like to do. That ray could be nice and short. It doesn't need to shoot very far, because it's only firing when you have a collision anyways. Alright, then we have a climb ladder speed. How fast is the character going to climb a ladder? So if your game is something about climbing ladders to the sky, then maybe your character is going to have a speed of 6, and you're going to go really, really, really fast. Alright, good job. Good job. Alright, now we have covered the entire PlayerController 3D script. I'm going to put the ladder climb speed back to 1.5 and fix my ladder. Now let's move on with the documentation, because we still have to look at the CameraFollow3D Class. This is the exciting part, because if you select your main camera, we've already added the CameraFollow3D, and we have to look at just a couple things. Focus, area, size. This is a cube that the camera follows. Now the camera's not going to move until the player himself touches the edge of this cube. You're going to see how this works. If he touches this edge of the cube, the camera's going to start moving. And then anywhere inside of this cube, the camera's not going to move. And then if he touches the edge of the cube back here in the Z, the camera's going to start moving in that direction. So you can change the size of this, and now the camera's going to move basically as soon as I make a movement. But something like 232 is good for this, but you could always change that. Now the Z-axis offset is how far away the camera is on the Z-axis. If you make it 20, it's going to be way out there, and if you make it 5, it's going to be right there. So just how far away on the Z-axis is the camera from the player. Vertical offset is how high is the camera from the player, because you know, maybe you want it down here, or maybe you want it a little bit above the players, or maybe you want it directly on the player. So that's the vertical offset. And then look ahead distance, X. How far are you looking ahead on the X-axis? Because when I go this way, maybe the camera needs to go farther in front of me. Even 3 would get me, or 4 would get me, so the character's probably on the edge of the screen almost. And this goes right along with the look ahead distance, and that's the look smooth time X. So how much is it going to smooth it? So if I go to 0, you're going to see that it instantly changes that X movement, and we don't like that. That looks awful. So if we put it to a 1, it's going to smooth that out a little bit, and we put it to 10, it's going to take a long time to finally catch up. Vertical smooth time is the same thing, but it's for the vertical movements. And the reason why you probably want to have different one here is because of falling. And when you fall, you want the camera to follow you. So if this was set to a 1, like the X value is, then my character is going to probably disappear off the bottom of the screen. So you want the camera to follow faster, probably on the y-axis. Oops, 0.2. That way, as you're falling, the camera keeps up with you. All right, that's the camera following script, and then we got the input system. Now the input system is what's called a modular input system. It works. It'll work with any input system. It works with Unity's input manager. It will work with Rewired. It will work with any input system, really. And there's more information about that in this tutorial series right here. So definitely check that out if you want more information on how the modular input system works. But the default one is the Unity input manager. So let's take a look at this. And we have the input manager here. In the game, it uses horizontal, vertical, run, crouch, jump, attack, cancel, and submit. There might be more in future versions, like fire, but we have an attack. So we have all these mapped to the Unity input. So if you were to select project settings input, you're going to find horizontal, vertical, fire, 1, jump, and submit, cancel, jump. And so each one of these inputs, of course, is mapped to, the left, the right button, A and D. That's the horizontal input. And so the name that you see right here is what is input to the input manager here. And so if you come into the Unity input manager and you change the name of something, or if you add your own inputs, you would just need to, if I change the name of this to vertical something else, then of course I need to put this name in the input manager here on the vertical axis. All right, I'm gonna make sure I undo that change. And then for the rewired integration, I'm gonna have a more streamlined process for this later. But for now, the rewired integration is best described in this tutorial series on the input system, so check that out. But again, if you're just using the Unity input manager, you can just stick with the defaults. Now we're going to look at the animation. There's 17 animations that can be used. 15 are included by default. Two of them are, the two that are not included are landing a jump when you're walking and landing a jump when you're running. By default, it just plays the landing a jump animation for all 3 states, but you could have different animations playing. And to see what that looks like in the animation controller, we could select the player, go to the animator, and we could see the landing, the jump, double click on it. This is a blend tree, which depending on if you're idle, walking, or running, it'll play a different animation. So if you're using the heroic traversal animations, you want to populate these. Actually, they already are with the heroic traversal animation controller. So the animation controller is here, and then it's described in the documentation if you want more information about each state. But there's not a whole lot that I guess I can describe here. Just the basic states. You have locomotion, which is a blend tree between idle, walking, and running, and that's playing anytime you're standing. You have the crouching locomotion, which is another blend tree between crouching, idle, and crouching when you're walking, so idle and walking. And then you have a jumping state which plays when you jump, so if I jump, that's going to play. And then right after I jump, the falling state's going to play. And so anytime you're in the air, or of course falling, you're here in the falling animation. And when you land a jump, you will go from the falling to the landing, the jump animation. So you can see that happen here. From falling, any state's going to transition to landing a jump. And you see him put his legs down. And then landing a jump's going to transition into locomotion because he's standing. And then from here, we've got the climb the ladder state, which of course is going to play when you are climbing up a ladder. He's on the far side of it. I need to drop off. So he's in the climbing ladder. You can see it plays backwards or forwards based on if you're going up or down. And then we have over here, we're going to do the edge grab loop, which is going to be coming up and mounting and going into idle. And from idle, you can either dismount or climb up. So dismount is going to go to falling, back to locomotion. Dismount, falling, land the jump, locomotion. And then if you climb up, of course you're going to transition into this mode, which is edge grab, climb up, and then back to locomotion. So that describes all of the animation states. And those are, of course, documented right here. You can take a look at those. Heroic Traversal Integration. If you're using Heroic Traversal, then you just need to, I have a test scene for Heroic Traversal here, and you could just bring Bandit into the scene and make sure that you add the character controller, all that regular stuff. But as far as the animator, you just need to select his controller, and don't use the player anim controller. Those are the animations that come default with the pack. If you want to use the heroic traversal animations, you could just select player anim controller, heroic traversal, and make sure that you have the heroic traversal folder with the animations in it. And then it's the same exact controller. There's nothing new to see here. Same exact controller, just different animations are filled out in there. So I could see I've got the heroic traversal guy, and he's gonna do all the same stuff, but with animations from the heroic traversal pack. Some of them, they doesn't have like climbing a ladder and crouching, so I have to use my animations for those. But other than that, we use as many animations from heroic traversal as we can. And moving on, we have help and support. Now I'm going to do a tutorial on how to write an email if you need. Well, let's skip that part. If you need help, write me an email or put a comment into one of the videos, and I will get to you, respond as quickly as I can. So thank you for watching. I hope this pack helps you out. Stay tuned for updates. 0.3 is going to come up next with more features added. See you guys in the next update.